right. I think we're up and running. Nice. Oops. Okay. So last day. Okay. We did what? We finished on, oh yeah, Okie Dokie Finance Company. That's not where I was. I want to do. Example 147. Okay. So what I'm going to do is I'm just going to steal this because you probably have it in your notes, or if you don't, pretend you do. Because I'm just going to steal this here. Okay. So just going back, because I couldn't copy all of it, right? So we have D has gotten some loans, right? 2,200, 1,800, and 1,300 on these different dates, right? And then she has to pay them all back on December 31st, right? So we went through drawing our timeline, that's important, right? And then we calculated how many days between each of these dates using our calculator, right? And then we started and we said, okay, so we had to find all those times. And then we found the future value for the first, or actually the last loan, right? The first future value, doesn't matter which order we calculate these in, but the future value of this last loan that she took out, we found was 13,1575. So we'll just keep going and find the other future values, right? Future value 2 and 3, add them up, find how much she has to pay back December 31st just to finish up this example. But I did tell you to go home and finish it, which I know y'all did. Again, if you didn't, just pretend that you did. Oh yeah, that took me so long, Emily. Why did it take you a long time? Well, I mean, not that long. Okay. Example 147, continued from last day. So, we found future value 1. How about we find future value 2 is also P times 1 plus RT, right? I don't have it here, which is very inconvenient, right? But the principal loan amount for future value 2 was 1,800 times 1 plus the rate for all of these loans. And we'll see today where the rate might change, right? So the rate for all of these was 7.25%, so 0.0725. And the time for the second loan was 148 days. So 148 out of 365. Time, remember, has to be in years. So, bust out the old calculator here. Which, even though I don't really like this calculator, it's becoming my go-to one. I don't know. It's really not. I don't like that you can only see one thing on the screen at a time. Right, so for the tests, if you have another calculator that's non-programmable, of course you can have that as well, right?
but you'll want to have this one for the days between dates and later for the other functions too. But, okay, so 148 divided by 365 times 0.0725, getting a little bit more brazen, doing everything in the brackets. And then I'll pause and show some work. 1800 times 1.029, 39726. So times 1,800, $1,852, and 915,068, right? But if you went straight to rounding to 2 decimal places, because it's money that we're talking about, that's fine by me, right? So 1,852.92. And then future value 3, same thing. P times 1 plus RT. The principal loan amount for the first loan was 2,200 times 1 plus the rate is still 0.0725. And the time we found was 191 days out of 365. So again, 191 out of 365 times 0.0725 plus 1. 2,200 times 1.037938,356. I write all my decimals. You don't have to write all your decimals, right? But you have to keep all your decimals in your calculator. Right? I'm writing them so you can make sure that you're getting the right answer. Right? And I don't mind writing out decimal places. It's relaxing. 2283.46, going straight to 2 decimal places now. Yeah. So the total owing on December 31st is future value 1 plus future value 2 plus future value 3. I'll move the equal sign over a bit because I'll need a little bit more room. Future value 1 was 1315.75. Future value 2 was 1852.92. And future value 3 we just found was 2283.46. So the total owing is $5,452.13, right? How much did she borrow? She borrowed first 2,200 plus 1,800 plus 1,300. 2,200 plus 1,800 plus 1,300. So she borrowed $5,300. She has to repay $5,452.13. Yeah, so depending on your rates, that might be good amount of interest, might be bad amount of interest. Who likes paying interest? Not me. Okay, so that's what's important, right? So we have to keep in mind the time value of money, right? So even though she borrowed some amount, right, over time with interest, we have to take that into account, right? So any questions about that one? Kind of chopped up example. So we've looked at solving for the future value. We've looked at solving for the present value, right? Let's look at solving for the rate, right? An example solving for R. So solving for R, if we have something like the future value, so we have two options, right? The future value is P times 1 plus RT, right? Or if we're dealing with simple interest, right, in our formula sheet, we have I equals PRT, so R shows up there as well, right? So depending on the information that we have, right, we can solve for R either way. We just use the formula that makes it easiest. So I equals PRT, right? So let's do this future value one, which is the most likely one that you'll use, right? So we have to get R on its own, so we divide both sides by P, so we get future value over P is 1 plus RT. We can ditch the brackets because they're not multiplying anything anymore. Oh, thank you. Okay. And then we have to subtract 1 from both sides, so future value over P minus 1 is R times T. Getting R on its own, we have to divide both sides by T, right? So I like to write my R on the left-hand side. Nothing's really changing though. Future value over P minus 1 over T. We could rejig this, but it's fine to leave it as future value over P, right? Because, hey Matt. Because we'll have the future value and we'll have P, right? Okay. Or this other formula is way easier to deal with, right? It's just unfortunate that we're not going to get that information all that often, right? We'll often have a future value, and yeah, you could calculate the amount of interest, right? I is the amount of interest from the future value and the principal amount, but I don't want you to get too comfortable doing that, right? If you have a future value, you should just use the future value formula. Right? So solving for R here, we just have to divide both sides by P times T, and then we're done. So R is I divided by P times T. So if I give you the amount of interest, right, then go ahead and use this formula because it's much easier. In my notes, I go through and show you how one evolves to the other, but I have a feeling you guys don't care, and it doesn't matter. Just know that they're the same, right? And we could go from the first one to the second one. What do you think you would do to change the first one to the second one? Could probably rewrite the future value as P plus I, right? That's true. Future value is P plus I. And then kind of go from there. Pull out the 1 over T, all that kind of fun stuff. But anyways, doesn't matter. Let's do an example. So, example 149. Let's go back in here. Oh, I have to steal these. Oh, I guess I have them. Nice. Oh, there's okie dokie. If $4,500 earned $384.32 simple interest from May 9th, 2005 to March 31st, 2006, what rate of interest was earned? Right, so we want to solve for R. Here, it's nice because we're given the amount of interest, right? So we can just go ahead and use the easier formula. So first, let's list what we have here, so we know that, oops, P, right, the principal amount is 4,500. We're told I is 384.32. And then we're not given T, but we have the days that we got the deposit and the withdrawal. So we denote it. Date 1 is May 9th, 2005. And date 2 is March 31st, 2006. Bless you. So to find T, right, to show our work using our calculator, we're going to set it up like this, right? We're going to have date 1, date 2, and the days between dates. So this is our list. And then up above, I just like to show the format that we have to enter our dates in. Month, month, dot, day, day, year, year. Right. We did a lot of practice last day, right? Figuring out days between dates. To indicate that I'm calculating or computing days between dates, I'm going to put a star here. Right? And that's how you're going to show that that's the one I'm calculating. Okay. So go into your date function, which is the number 1 button. So second date. Okay. Our first date is May 9th. So 05.09 and the year is 05. Okay. So 05.0905, enter. Right, enter, you have to hit enter to store it. Date 2 is March 31st, so 03/31/06. If you tried to enter 05 again, it would complain, right? Date 1 has to be before date 2. Oh, scroll down. So use the down arrow button to scroll down to date 2, and now you can enter date 2. So 03.3106, enter. And then now you've got your dates in there, so now you can scroll down one more to the days between dates and hit compute, CPT, the top left-hand corner, CPT compute. And you should get 326. Is everyone getting 326? Nice. Cool. Yeah. I know, I don't know what that is. I don't know.
Actual ACP is just the actual date, and 360 is for doing 30 days out of 60 days a year.
Oh, okay. Okay. Nice. Cool. Yeah, because we want the actual days between these dates. Nice. Thanks for looking that up. Cool. Okay. So then T must be 326 divided by 365. So now I have I have P, I have T. Right? So now I can use I equals PRT. The amount of interest was 384.32. P was 4,500. R is what we're trying to solve for, and we just found T is 326 over 365. If you wanted to solve for R right away here, that's fine, right? I like to just plug stuff into the formula usually, and then I just solve from there. But however, whichever way you want to go about doing it is fine. Right? You're going to plug stuff in either way. Okay. So then I'm going to say that R must be 384.32 divided by 4,500 times 326 over 365. Okay. Just pulling those things, multiplying R over to the other side. And then switching sides. In one foul swoop. So I'm going to simplify the denominator first. So 326 out of 365 times 4,500. I get 384.32 divided by 4,019.178082. So my rate must be, so I want to do 384.32 divided by what's already on my calculator, right? So you can use the second answer. So above the equal sign, if you hit second equals, it'll just recall the most recent answer that it gave you. So I use that quite a bit, right? So now I can just say, okay, well, this was, so the 4,019 is the last answer it gave me. So now I can just enter 384.32 divided by second answer. Second answer, it'll show me the last answer that it gave me, right? And then hit enter, right? Just makes it a little bit easier to keep all our decimal places in our calculator. So now we have 0.0956215541. Right. So the rate must be 9.56%. Cool. Any questions about that one? Nice. All right, so same idea. Oh yeah. Oh, here, I'll just change it for you. Oh yeah, that one's brand new, right? Yeah, that'll mess you up. Okay, so same thing to solve for t, right? Very similar. So solving for t, we'll solve for r. Oh, you mean using the days between dates? I mean from the formula. Yeah. So if you have the future values p times 1 plus rt, or whether you have the I equals prt, right? We need to be comfortable solving for t as well as for r. So what you'll find is for each of these sections, I introduce a formula, and then we go through and we solve for each one of these terms, just kind of work through solving all of the terms individually. Okay. So, very similar situation to what we had for R, right? So let's use the first one to solve for t now. So we have to divide both sides by p, 1 plus rt. Subtract 1 from both sides, so we get future value over p minus 1 is r times t. And then to solve for t, we have to divide both sides by r, future value over p minus 1 over r. Or if we're lucky enough to know the amount of interest, that's great, because then we can just divide both sides by p times r and be done with it. So let's have a look at example 155. Oh, I think this question's hilarious because my parents have neighbors that they hang out with, and their names are Janice and Wayne. But once they've had a couple, they call themselves Wayne and Janie. So here, Janet, which is pretty close to Janice, borrowed $15,000 from the Bank of Wayne, which is also hilarious. So anyways, so Janet borrowed $15,000 from the Bank of Wayne on November 5th, 2001 for a new necklace. She had to have it. The Bank of Wayne charges 7.45% simple interest. So interest accumulated amounted to $1,534.67. On what date was the loan repaid? Okay. Oof. Yeah. Shoot is right. So I'm going to map this out with a timeline. We don't really need to, right? But it's good to kind of see some timelines. So we start with our start date, go to our unknown end date, right? And this is going to be kind of a way to map out the information that we're given, right? So she borrowed money on November 5th, 2001, and we want to know when did she return it, right? So we put our dates above and the amounts below the ticks. Right? So we have $15,000 that she borrowed. She had to have it. And then we draw this arrow saying, okay, it sits there, she borrows this money and she has to pay interest. So in the end, right, she has to pay back 15,000, oops, plus 1,500 and can't remember what it was, 34.67, right, which is what? 16,534.67. Yesterday I screwed that up and I said 1,600. That would be nice. Borrow 15,000, pay back 1,600. It doesn't work that way. Right? So this is your P plus I. Right, P plus I is the future value. Right, so from here, this is why I say, okay, you could take your future value and subtract the principal amount to find the amount of interest. But I don't really want you to do that in general, right? For this one, I give it to you, I give you the amount of interest, or I don't, but we're given the amount of interest, so then we can use it, right? But also it's good to remember that the future value is just P plus I. So we also know the future value. Okay. So, all right. We put our time on this arrow. We don't know how long it's been sitting there. So we can just say equals question mark. I don't know. Right. So the rate we're told is 0.0745. And here's our complete timeline. So you just put the rate anywhere. Right? You'll put it on the arrow if there's differences between each of the arrows, right? But if you have the same rate for all the arrows, you can just put it somewhere in the corner. Okay, so first thing we're going to do is we're going to find T, right? So first, find T. So we know I is P times R times T. We know I is 1,534.67. T was 15,000 and the rate is 0.0745 times T, which we have to solve for. So T is 1,534.67 divided by 15,000 times 0.0745. 15,000 times 0.0745. So T must be 1,534.67 divided by 1,117.50. So again, I'm going to use the second answer, turning out to be very handy, right? 1,534.67 divided by second answer. I get a T of 1.373306,488 years. It's hard to know what 0.373306,488 of a year is, right? So we need to convert this to the number of days, right? Because we want to know on what date did she repay this loan, right? So that means that we have to know the number of days to use the days between dates function on our calculator. Okay. So we need to know T in days, right? So T is going to be 1.373306,488 times 365 to get it in days. So times 365, I get 501.256868. We've seen this before, right? Where we can't have 0.256 of a day, right? And if she repaid on the 501st day, it wouldn't be quite enough, right? So we have to round up to 502 days. Okay. 502 days. We always round up for the number of days. Okay, so now we have this situation. We have date 1 showing our work that we're going to do on our calculator. Date 2, which we're trying to solve for, so I'm going to put a star by it. And we know the days between dates. We just said was 502 days. Date 1 was November 5th, 2001. Okay. So November is 11/05/01. Just like we did before, you go into your second date function. And so 11.0501, enter. You can scroll past date 2 because we're going to come back to it and ask it to compute it for us. All right, so you can just scroll past it, ignore it. Days between dates, you're going to change to 502, enter. And then scroll back up to date 2 and hit compute. It was a beautiful Saturday, March 22nd of 2003. Also my dad's birthday. Saturday, March 22nd, 2003. The loan was repaid on March 22nd, 2003. As long as you show me that that's your answer, yeah, that's probably fine. Right. But you want to make sure that when I'm marking that it's easy to spot where your answer is. Right? But yeah, as long as I can see it. Good. Cool. This is a fun twist. No? Okay. All right. All right. How about, we've already kind of sort of talked about it. So we're going to start talking about equivalent payments, right? So a scenario like, okay, so I borrow $100 from you and I say, oh, I'll pay you back with 4% interest 2 months from now. And then a couple of weeks come and go, right? And then I'm like, oh, I can't pay you back when we said I was going to pay you back. I'll pay you back right now. Bet you didn't see that coming, right? How much do I have to repay then? Because I've already agreed to pay some amount, right? So I have to figure out an equivalent payment for today, right? Or usually we're postponing our payments, right? So I'll pay you back 3 months from now, right? And then, so then we have to figure out, okay, well, what's an equivalent payment on that later date to what we already agreed on, right? Because interest and things get messy, right? No, goodness, no. So in 4.6, we're going to talk equivalent payments. And this is where it's going to start to get very important that we have our timelines figured out. Okay. So equivalent payments are just 2 payments that enable you to end up at the same dollar amount at a later date. To end up at the same dollar amount at a later date. Yeah, but usually it's later. We like to postpone our payments. So we're going to be talking a little bit about payment streams or referring to payment streams. So a payment stream is just a series of 2 or more payments required by a single transaction, right? So I borrow $100 and then I say, oh, I'll pay you back $20 each week for however long, right? So that's a payment stream. So a series of 2 or more payments required by a single transaction or contract. Transaction or contract. And we'll also talk about the focal date. The focal date is the date that we're going to bring all our calculations to, right? So on the test, I try to make it easier by saying use whatever date as the focal date, right? So that's just telling you to bring all the calculations to that focal date. So the focal date is a date of importance to our calculations it's the date we will bring all our calculations to. You'll see what I mean. Let's do example 159. So a particular investment pays $800 payments for 8 and 12 months from now, right? So you go to the bank and they say, you give us this amount of money and we'll give you payments of $800 4 months from now, $800 8 months from now, $800 12 months from now. So what's the most an investor should be willing to pay for this investment today if money earns a rate of return of 6%? Use today as the focal date. Right, so how much is $800 4 months, 8 months, and 12 months from now worth today? Right, because you wouldn't want to pay more than that because then it's not worth it, right? If you have to pay more than that, you can just invest your own money and have it pay you more than $800 at each interval, right? And so that's what we're trying to figure out, right? So there's going to be a chunk today that's going to be equivalent to this payment scheme, 800, 800, 800, right? And we're going to figure out what that is. Okay. So I feel a timeline coming on. Feels good. Right, so we start our timeline same way every time. So first thing we're going to do is we're going to figure out how many dates we have, right? Because the number of dates is going to determine how many ticks we have on our timeline, right? So we know we have to use today as the focal date. So we're going to start today. That's going to be a tick. And then we have a tick at 4, 8, and 12 months from now, right? So we've got 4 ticks in total. The spacing doesn't matter on here, right? It's just for visualizing what's going on. Okay. So I just try to make them as evenly spaced as possible, but it's hard. Okay. So we're gonna write, okay, so we've got today, that's our first tick. And then here we've got 4 months, 8 months, and 12 months from today. So they don't necessarily have to be dates. Right? Often they'll just be in reference to today, usually. So we're told, okay, so with this investment, I'm gonna get $800 here, here, and here. And we want to know how much is this worth today, right? So it says use today as the focal date. So I'm just going to say, okay, focal date. And this is what I mean by when I tell you the focal date, right? I'm trying to help you out and saying that, okay, all of these payments, they're going to get brought back to the focal date, right? So the focal date is where we're going to draw all our payments to. In this case, the so backwards to the principal amount. So any backwards arrow is going to be calculating a principal value, right? Any forwards arrow is calculating a future value. So I like to start my arrows from the closest one to where I'm drawing it to, right? So they don't get all clustered. So this first $800 becomes some P1. P2. P3. So adding these up, this is the total value of the investment today. Right. On each of the arrows, right, we put time, right? The time for this first one is 4 out of 12, right? 4 months is 4/12 of a year. The second arrow, we have 8 out of 12. Nice, we don't have to do days between dates. We were getting good at it though, right? This third one, 12 out of 12. And for consistency, I'm going to keep it as 12 out of 12, but if you wanted to just do 1, that's fine. And because the rate we're told is the same for all of these, so I'm just going to jot it down here. Anywhere. So this is a complete timeline, right? Everything you need, nothing that you don't, so nothing on here is optional, right? And remember I said the timeline on a question out of 10, for example, this question would be out of 10, right? The timeline is worth 4 marks. It's a lot, right? Should be worth more even, maybe, right? Because it's just showing me that you have understood the question and you're plotting out what you're gonna solve for, right? What you need to do, because now we just have to solve for P 3 times over, right? So I look at this and I say, okay, I have to solve for P 3 times. I'm just gonna rearrange the formula and solve for P once, and then I can just use that formula, right? Instead of rearranging it all the time. So I'm going to start with the future values, P times 1 plus RT. Solving for P is pretty easy, so we get P is the future value over 1 plus RT. Now we can go ahead and solve for P1. The future value, and I should be writing out my bare bones formula every time, but it gets so annoying, so I don't expect you to either. We should be writing out the empty formula, but so the future value for P1, the future value is always the one on the right-hand side of the arrow, right? So it's going to be 800 for each of these. Okay. The rate is the same for each of these, so the only thing that's going to change, right, is the T. Okay. So we have 800 over 1 plus the rate is 0.06 times T for this little guy is 4/12. I'll simplify my denominator. 4 over 12 times 0.06 plus 1. 800 over 1.02. I'm going to go straight to a dollar amount, $784.31. On to P2. We know the future value is 800 again, over 1 plus 0.06 times, now we have 8 over 12. Eight over 12 times 0.06 plus 1. 800 divided by 1.04. Going straight to a dollar amount. 769.23. Gets a little tedious, right? But I don't know about you guys, I like tedious. Makes me feel like I know what I'm doing. It's nice, it's relaxing. So we just keep going. P3, 800 over 1 plus 0.06 times 12 over 12 this time. So 800 divided by 1.06. $754.72. Oops. So then the total value today, right, is P1 plus P2 plus P3, which is 784.31. Oh, I won't do my dollar sign quite yet. 784.31 plus 769.23 plus 754.72. I'll Martha Stewart these. Do you guys know what I mean when I say Martha Stewart? I just have them ready. I just put a pie in the oven and I just pull up a perfect one out. They're ready to go. 0.26. Sometimes you just gotta Martha Stewart this stuff. So, well, so what this is saying, right, is that, so 2308.26. So if the bank said, hey, give us $2,200 today, and they're feeling desperate, right? So if you give us $2,200 today, we'll give you 800. That's a good deal, right? Because the value of 800 today is $2,308, right? Yeah. So they're kind of paying you to get your money right away, right? And then you get a good deal in the return. That'll never happen, but if someone said, hey, if you give me $2,350 today, right? That's not a good deal because 800 is only worth $2,308 today, right? So that's how we use these.
Why does it matter when it's worth?
It's just the equivalent payment, right? So the equivalent payment, I'll just write it down here. We found 2308.26, right? Just so I have it on the same graph here, right? Because 2308.26 is equivalent to 800 at these time intervals, right? So if the bank is saying they'll charge you more than this, right, to give you 800, then you would just say, no thanks, I'll just invest my own money, right, and get a little bit more than 800.
That's if the interest rate is at 6%.
That's right.
Like if it was lower than that number, it would be higher.
Yeah. So the equivalent, so that's the idea behind equivalent payments, right, is that 2308.26 today, right, is worth what this would be on that time interval. Just like if you think about just P1, right, 784.31 is equivalent to $800 4 months from now, right? So 784 whatever is worth $800 in 4 months, right? So those are equivalent. Sometimes, but we'll see future values too. Yeah, we'll see others too. Okay, so I'm going to erase this from the notes because that was just for me to see. Any questions about that one? It's a little, but good to know, right? I'm gonna go out on a limb and say, yeah, probably. We're gonna dissect this stuff pretty hard. Yeah. So just the term, I think I already used it. Discounting is when we take some future value and discount it to the principal amount, right? So when we bring it back and find the principal value, then we're discounting. Right? So just as a term that I tend to use, let's throw it in there. So discounting is the process of calculating a payment's present value. A payment's present value or principal value. We've only been calling it principal value. Once we get into compound interest, we'll start calling it present value, right? And I'll probably let it slip. But principal, present value, they're all the same. Okay. How about another one? Another one. Ding, 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 ding. Not even sure that was a song. Could be. That's who it is. Yeah, another one. Ding, 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 ding. Example 161. So calculate the fair market value, right? Which is just the equivalent amount, right? So the fair market value of the scheduled payments 60 days from now if money can earn 8.5%. So the payments are $1,000 today, 1,570 days, and 2,210 days. All right, so what's the fair market value 60 days from now? That's what we want to know, right? And so because we're interested in the 60 days, even though it doesn't tell us that that's the focal date, right? If I want to know the fair market value at 60 days from now, that's going to be my focal date. Right? So of course we need a timeline. So we'll start here, start with our basic timeline. Okay. So we want to figure out, so first we'll look at the payments. The payments we have today in 70 days and in 210 days. Okay. 60 days isn't one of those dates, so we have to throw that on there as well. Right, so we have 4 dates that we need to draw on here. So we need 4 ticks. Throw in another 2. Call it a day. No.
Done.
So chronologically, right, we've got today, 60 days, 70 days, and 210 days. So we've got today, 60 days, 70 days, and 210 days. I'd almost say that the hardest part of making your timelines is figuring out what dates you have to draw, right, and where to put them. They have to go chronologically. Yeah. Oh no. Yeah, so here, right, I just put the ticks kind of evenly. That's why I figure out how many ticks I need, and then I just try to put them as evenly as I can. Right, because here, there's only 10 days between here, but lots of days between here and here, but it doesn't matter. Right. Just keep them nice and kind of spread out. Okay, so let's put the amounts that we are paying or are getting paid. It's not even clear, it doesn't matter. Okay. So we're paying, let's say we're getting paid, that feels better. $1,000 today, $1,500 in 70 days, and $2,000 in 210 days. But we want to know, okay, so the bank calls us and says, hey, we know it's only been 60 days since we made up this contract, but how about we pay you today, right? We missed that payment, this would never happen. We missed that first payment that was supposed to happen 60 days ago, but we'll pay everything today, right? And then they ask you how much they owe. You have to figure it out. Again, would never happen. But not like that, at least. Not with the bank. Okay? So this is our focal date, right? So that's what I mean by we have to draw all these payments to figure out what they're worth at 60 days. Okay? So this one, we have to pull forward to 60 days, right? And these we have to pull back, right? So we're discounting these ones to 60 days. Okay. So we draw this out. I'll start with the 1,000. My arrow's going forward, right? So that means I'm calculating a future value. So I'll call this future value 1. Okay. Then my 1,500, I have to pull it back. I have to discount it. And even though this is my first P, I'm going to call it P subscript 2. Okay. Moving towards the subscripts are just denoting the order of my calculations. Right? The order that we calculate these doesn't matter for this example, but we'll see one where it does later on. Okay. And then this last one has to get discounted to some P3. And then the sum of these is the fair market value. Right. So this one single payment is going to be equivalent to the original payment plan. Okay. On our arrows, we have to put the time, right? So the time between today and 60 days is just 60 days out of 365, right? We have to be careful though, because the time between 60 days and 70 days, that's only 10 days. So T is 10 out of 365. And then don't be a hero, 210, just use your calculator, 210 minus 60, T is 150 out of 365. Just use your calculator. Okay. So that's one thing to keep in mind, right, is even though we've got these 7210, right, those aren't the number, those are the days from today, not the length of the arrow, right? The T has to be the length of the arrow. Okay. And we've got the same rate for all of these, so I'll just jot it down here, 0.085. So this is our complete timeline. Nice. It's beautiful. Let's get to work. So we have to find future value 1 is P times 1 plus RT. Okay. P for this one is 1,000. Times 1 plus the rate for all of these is 0.085. And time for this little guy is 60 out of 365. So 60 divided by 365 times 0.085 plus 1. Stop and show some work. 1,000 times 1.01397 2603 times 1,000. Rounding to 2 decimal places right away, 1013.97 because we can. P2. I already solved for P earlier, right? Same thing on the test. If you've already solved for P once, you can use it, right, in later sections. So P is the future value over 1 plus RT, right? So the future value for P2 is 1500, right? And the time is 10 out of 365. So 1500 over 1 plus 0.085 times 10 out of 365. I'll simplify the denominator first. So 10 divided by 365 is tiny times 0.085 plus 1. 1500 divided by 1.00232867. 1500 divided by that answer, 1496.51. P3. Future value over 1 plus RT. Future value for P3 is 2000 and the time is 150 days. So we have 2000 divided by 1 plus 0.085 times 150 over 365. 150 divided by 365 times 0.085 plus 1. 1.0349 31507. 2000 divided by that, $1,932.50. Now we have all three of these components, right? So we can calculate the fair market value by just adding all of them up. So fair market value at 60 days is future value 1 plus P2 plus P3. Yeah, maybe I should. Or at least I won't be scrolling. Yeah. 1013.97 plus 1496.51? Yeah. Plus 1932.50. Martha Stewart this, and I get 4,442.98. Is that what everyone's getting? No. Oh, it might be something I did. Which one are you getting? 5456. I still get this. The 4,400. Something happened. Something happened. Nice. So the fair market value today. That's good. Got it. Okay. Of course, on a test, if you got this far, then you just had a little typo here. And maybe take half the mark off. Little typos aren't worth that much off. They're just half a mark off. If it's obvious that you just had a slip on your calculator or something like that, then No biggie. Okay. So not to worry. Okay. Any questions about that one? We're gonna break out the big guns. Yeah, we are. Example 163. Holy word problem, Batman. Whoo. Okay. Here we go. So let's read this sucker. 4 months ago, from today, of course, Teresa borrowed $1,000 from Josh and agreed to repay the loan in 2 payments to be made 5 and 10 months after the date of the agreements. Right, so 5 and 10 months from 4 months ago. Right?
I don't like that.
I don't like it. Well, let's see what we can do with it. Each payment is to consist of $500 of principal and interest at the rate of 9% on that 500 from the date of the agreement. All that's saying is I'm going to borrow $1,000 and I'm going to pay you back 500 in 5 months and 500 in 10 months. Right? So that's all that's saying. Today, Teresa's asking Josh to accept a single payment 3 months from now to settle the debt. So like I said, oh, and then what payment should Josh require if money can now earn 7%? So now the interest rate has changed, right? So the interest rate went from 9% to 7%. The hardest part, I think, is going to be to figure out how many dates we have and then figure out where they all go on the timeline. Right, because we've got, okay, so she borrowed money 4 months from today, right? So we have to have 4 months ago today, and then we have to have, so she was gonna make payments at 5 and 10 months from today, but she's gonna pay it today. And then she says, oh, well, wait a second. I'll just pay you a single payment 3 months from today. Right? So we have to figure out where that 3 months from today fits between 5 and 10 months from 4 months ago, right? So we can put these on the timeline, okay? There's 2 ways that we can do it, but I'm just gonna put all these dates in terms of where they are from today. And I think that's the easiest way to do it, even though there's a quicker way to do it, but I'll show you both. But I like to just say everything in terms of today, right? Where is it from today, right? And we know that we have 5 ticks. So let's start with our 5 ticks, kind of go from there. So start with, with our timeline here. I should have given myself more room. And squeeze 3 ticks in here. It's always lofty in the beginning and then gets crammed in the end. I should start writing my ticks from the right and then it'd be the opposite. Doesn't matter. So 4 months ago, so I'm going to start out here. I know this is my first tick. 4 months ago. Or maybe I'll say from today. Right. And then, yeah, let's gamble and say the next tick is today. Right. Because we know that the first payment wasn't supposed to be until 5 months from the agreement date. Right. So I suspect that the 5 months is going to be the next tick, right? So that's why I'm going to write it up here. 5 months from agreement date. But you want to give yourself a little bit of room in case we have to move these dates around. So then 5 months from the agreement date, which was 4 months from since today, right? That's only 1 month from today. Yeah, kind of. Right? So like I said, I'm putting everything in terms of where it is from today. And then I've got, I'm gonna make a single payment 3 months from today, right? So I suspect that the last payment 10 months from the agreement date is gonna be the last tick, right? Because 10 months from the agreement date is what, 6 months from today, right? So I have to have a payment 3 months from today. And up here, we're 10 months from the agreement date, which is 6 months from today. What could you have done instead? You could have said, okay, well, I need to figure out where this tick, and this tick go. Right. So then you could have said, well, I know 5 months and 10 months in relation to the agreement date, right? So why not just make the 3 months from today and figure out what it is in relation to the agreement date? So 3 months from today to 4 months ago, right? That's 7 months from the agreement date, right? And so that's how you could figure out which one is which as well. Right, so either way is fine. I'll just put it on here.
We're skipping payments on today.
Yeah.
Okay.
We don't actually have anything going on today. We just need to have kind of a reference point, right, for figuring out our dates. So you could have gone without today altogether, but it's kind of hard to figure out where these dates go then. Right? So you don't have to have today, but I don't think that way, right? Yeah, but you could say, okay, well, from today, that's, and then 4 months ago. Then you could just say that that's 7 months from agreement date. So you could have gone that route as well. Whew. Okay. All right. We're okay, we're still breathing. So she borrowed $1,000, right? So the next thing we have to do is put these amounts. So we're gonna say, because she's breaking this $1,000 up, I'm gonna write 500 and 500, right? Because she's gonna pay back 500 5 months from now and 500 10 months from now, right? So I'm gonna split them up over here. So I've got 500 and 500, but then I'll just show that this is a total 1,000 borrowed. Okay. That's right. So then just to show what they mean by this $500 of principal and interest at a rate of 9% on that 500 from the date of the agreement. Okay. All that's saying is that, okay, well, this 500, I have to pay back some future value, right? The arrow's going forward, so we have to calculate a future value at 5 months from today. or from the agreement date, sorry. So this would be future value 1. And then this next 500, I was supposed to repay back future value 2, 10 months from the agreement date. This was the original payment plan, right? So let's put our T's on here. So the T is the length of the arrow. So we know that the length of this first arrow is 5 months. And the length of the second arrow is 10 months. For this first agreement, the rate was 9%, but we know that the rate's going to change. So when the rate changes, we put the rate on each of the arrows, right, to indicate which rate goes where. So we say, okay, here the rate is 0.09. Here the rate is 0.09. So this was our first agreement. Okay. Then she says today, she says, oh, wait, I'll just pay it all back 3 months from now. Right? So then we have to restructure this loan. So here we are today. She says, oh, I'll just pay you everything back, right? 3 months from now. So what we want to do is we want to figure out what this value and this value is worth 3 months from now. Right, making 3 months from now our focal date.
So it would just be 1,000 to the 3 month mark or 7 months and then change the rate.
So then, because now, instead of paying this amount back here where she was supposed to, she's technically borrowing it again, right? She's re-borrowing this future value and moving it more, right? So this transitions from a future value here. Once you calculated it, you're going to use it as the principal value to calculate this new future value, right? But also she doesn't have to wait this long to pay this one back, so it's going to get discounted a little bit, right, to some principal amount. So this is where the subscripts become important, right? Because we have to indicate, okay, well, at first I have to have future value 1 and 2 because I need to use those to find these next ones. Right? This one is going to become some future value 3. And this future value 2 is going to get pulled back to some P4, right? I'll just put a little note here that this is our focal date. So adding these up, that would be the lump sum that she should pay 3 months from today. Right? So it's the total owing 3 months from today. Nice. We have to put our T on these last arrows. Yeah. Yes. Well, it is fair because we're doing it together. But I know what you mean.
So much. It's not a fair chance. Yeah. I can only remember.
But it's all logical.
No. I can only remember about 5 steps at a time. Just the
Okay.
And then you gotta mix that.
I'll boil it down to 5 huge steps.
Oh, no. I don't think so.
Well, you can't have it all. we need to put the length of each of these arrows, right? The length from 1 month from today to 3 months from today is 2 months, right? 2 out of 12. And remember, the rate has changed here, so the rate now is 0.07. And then for this last arrow, between 3 months and 6 months from today, we have 3 months. 3 out of 12. The time? No, time can't be negative. You're just looking at, okay, what's the length of time between 3 months and 6 months from today? Right. And then the rate here is 0.07. Now we've boiled down this huge question to a timeline, and it is a thing of beauty. Okay. So now we just get to work, right? So we have to find future value 1. Future value 1. Is P times 1 plus RT.
Becomes the number that you use in PV1?
Yeah.
Okay.
In FV3.
Yeah.
Yeah.
That one becomes PV1?
Yeah, exactly. I'll make a note of it when we get there for sure. Because it's the tricky part, right? Kind of becomes from a future value to a principal amount to calculate a new future value. So we've got future value 1. We have a principal amount of 500 times 1 plus R, which is 0.09 for this guy, times 5 out of 12. Five out of 12 times 0.09 plus 1. I have 500 times 1.0375 times 500. 518.75. Let's do future value 2. P times 1 plus RT. P again is 500. 1 plus the rate is still 0.09. And T was 10 months. So 10 out of 12 times 0.09 plus 1. 500 times 1.075. So times 500, 537.50. Okay. So this was the original agreement, right? $518.75 5 months from then, and then $537.50 10 months from the agreement date, right? So now she has to borrow that $518.75 for just a little bit longer, right? But she's also getting a discount on the future value too, right? Because she's pulling it back a little bit earlier. Okay. So to calculate future value 3, we use future value 1 as the principal amount. Right? Because that's what we said here. Okay, so we have to pull that future value 1 forwards to future value 3. So then the time is 2 months and the rate is 7% now, right? Got to keep track of those. Future value 3 is still P times 1 plus RT. just to emphasize it, I'm going to say that future value 3 is the same as future value 1 times 1 plus RT, right? Just to show that those two are going to be the same, which is, oh, what was future value 1? 518.75. Times 1 plus 0.07 times, and the time I've already forgotten. I said it, 2 out of 12. Thank you. So now 2 divided by 12 times 0.07 plus 1. I get 518.75 times 1.01166 repeating times 518.75, 524.80. So now we can find P4, right? P4 uses future value 2 as the future value. P4 is future value 2 over 1 plus RT. So 537.50 over 1 plus, the rate is 0.07 now. And I think it was 3 months, right? Yeah. Nice. Okay. 3 out of 12 times 0.07 plus 1. 537.50 over 1.0175. I get 528.26. So then we can say the total owing 3 months from today is just future value 3 plus present value 4, right? That's what we had to find out. 524.80 plus 528.26. $1,053.06. Cool. Think you can handle it? No? How about we call it a day, because that was plenty of work for one day.